Good morning, and welcome back to another episode. We, I think, are about to start on our import-export config stuff. I go just grab the project really quickly, and we run it. I think all the core gameplay stuff works now. Right, we come in here, can edit your piece set. Bless me. And then we can come in here and you can play with it. And it all works like it should, including squirrely stuff. So I'm assuming if I do this right, tick, tick, like that's the kind of, if the game is going to be fun, little things like that are what are going to make it fun, right? It's the ability to do silly things where you can chunk a piece in somewhere it shouldn't normally be able to go. So that's all working. We have a working menu. It's admittedly all a bit ugly, so these don't have hover states yet. I think this all wants hover states as you hover over things that you can click. But that's by the by. The next thing on my list, I assume, I go grab my README I've kept track of, is this. So I'm imagining it's a silly little game. I don't think I'm going to get loads of people playing it, but maybe somebody plays it. They find a set of pieces that are kind of fun, and either they would like to be able to save it themselves, play again later, or they'd like to be able to save it and then send it to a friend so their friend can play it. I think the easiest way to do that is to have a kind of like export as a string. So I want to be able to encode this information as a string, basically. So these 8 pieces and their rotation centers. And then you be able to import that. So there's 2 ends to that. The export problem, I think I basically just need a button that you press that copies something to your clipboard. That doesn't seem too hard. Although I don't actually know how you do that, so maybe make a little list. How to copy to clipboard. I'm also going to need a little kind of like typable area for you to input your thing into. So button to export string, copy to clipboard, text input area, and a paste from clipboard button. So some limitations we have at the minute, which we could change. My font only has capital letters and numbers in it. So if we want to be able to draw anything more than that, we're going to have to go and add to the font. Or, out of laziness, I could just make it so that the import-export string just has case-insensitive letters and numbers. It's kind of the way I think I'm going. Just as a way to bash this out, because there's not a lot of information here to encode, right? Alright, so I think the first thing I would like to do is we might have a little just random play and see how we copy something to the clipboard. And then how do we encode piece config? So I haven't thought about that at all, honestly. So we might not get a lot of code written today, is what this means. But I think there's some stuff to work out, so let's have a think. We've been using glfw. I assume glfw will have clipboard stuff. In fact, if I just try clipboard, it might tell me about pasting as well, mightn't it? Beautiful. What do you say? Functions, it has set clipboard string, get clipboard string. Function returns the contents of the system clipboard if it contains or is convertible to a UTF-8 encoded string. Function may only be called from the main thread. The returned string is allocated and freed by glfw. You should not free it yourself. Interesting. And it's only valid until the next call. Okay, so copy it, basically. Get the value, copy it, because you can't guarantee, I guess, its life cycle. Sorry, I'm sniffing horribly again. Terrible habit. One of those things that I think you don't realise until you start recording yourself talking at length. How hard it is to not just be making gross noises all the time. So, apologies. Did it again. I have to lean away like Tezonde when I want to sniff. Okay, so you just need a window. Ooh. Okay, yeah, so the get doesn't have to take in a pointer because they handle it. They just return you a pointer. Cool. That doesn't sound too hard, actually. Shall we... so we even care to add a button? That sounds easy enough that I don't think we need to, like, test it out. I think we can just trust that will work. This is the more fun bit. How do we encode piece config? So let's draw a diagram. Because like I say, I haven't thought about this, and I think this actually sounds like the hard. If there is a hard part of the problem, it's here. So our game config is 8 pieces. Where that is a 25 cells that are filled or not filled. And a rotation center. And what we would like to encode that in is the letters A through Z and the numbers 0 through 9. I've got a tickle in my nose like I'm going to sneeze again. And it's just not coming. Okay. So, how do we encode one piece? And then do we encode a number of pieces? I guess one thing is we would like... So the game lets you, currently, and I think I like this, leave specific pieces empty. So, like, you can come in here. I can remove this one, and I can put this one in. And that should then work. Right, if I slam through a load of these, like, the game doesn't break. And part of what that does is it means that you can kind of pick what colors you want things to be. Right, so things are... The color of the piece is determined by which of these grid cells it's in. So if it's 0 through 7, which means I can't just say, well, I have 3 pieces and store the 3, because if actually you got rid of this one, then when you imported the config, it would shunt everything down, right? So that's something to think about. So I think we do need to encode the state of all 8. Is what that means. The 25 cells are just filled or not filled. So I guess really what we've got is, you know, a set of 25 bits. The rotation center, very worth thinking about, is a number between 0 and 5, I think. All right, so what we've got is 25 filled or not. These are really 25 bits of information. The rot center is an X and a Y, which will be from 0 to 5, I think. Because, again, if I come into my editing... Oops, what's going on? It could be 0 if it's here, and then it's 1, 2, 3, 4, 5. Right, so it's more generous than... Oh, sorry, there's more possible values than there are cells. The cells go 0 to 4, but because you count the intersections between them, you get more. So they are 0 to 5 inclusive. Which can be represented as, what, 3 bits? Because 1 bit gets you 0 or 1. 2 bits gets you up to 3. 3 bits gets you up to 7. Is that right? All right, because if 0, 0, 0 is 0, you go 0, 0, 1 is 1. 1, 0 is 2. 0, 1, 1 is 3. Right, and you keep going. Oops, on that one. 1, 0, 0 is 4. 1, 0, 1 is 5. How have I ended up at 6? This one. That'll be why. The reason I was suspicious there is it should have been 1 less than a power of 2. Right? So that the reason it's that number is it's 2 to the 3rd power. Right? It's 2 to the 3 minus 1. Is how many bits of information you need to store that number. So if that's everything we need, that's 28 bits of information needed to encode the value. Per piece. Right? 28 bits per piece? Well, then we have 8 pieces. Which says it would be 28 bytes. Cool. That doesn't sound too bad, does it? How do we turn that into a string? Because not all bit strings, sorry. Not like all bit strings are going to be valid like UTF-8 outputs. Not really sure how we're going to do that. So encoding to a string where our characters available to us are A through Z and 0 through 9. That's 26 values. That's 10 values. We've got 36 values available to us. Do we just treat the 28 byte value like it's a 36? We treat that like a number system. So you know how hexadecimal is 0 through 9 and then A through F? So the letter A is a value of value 10 and B is 11 and C is 12. Do we just continue that? And we make 36 base numbers. So our 28 bytes is really a binary number. And then we're going to give you the 36, or the base 36 value or representation of that same number. I think that should work. It might take a bit of thinking, but I think it should work. All right, so your config be a 28-bit bit string, which we then interpret as a binary interpret as an unsigned int. Get you a value we can talk about in base 10, right? It's just a number. And then we want to convert to a base 36 representation. And that's our string. That doesn't sound crazy to me. And I think it's relatively extensible, right? If there's more information that we would like to start including, we just have more bits in our thing. It's quite neat that because we've got 8 pieces, it always comes to a round number of bytes. But even if it didn't come to a round number of bytes, right? Let's say there's some header information we had to include as well. We can just pad the start with zeros, so it doesn't change the numeric value. I quite like that idea. Just trying to think if there's anything else worth thinking about. This is where it'd be nice to have been doing this live. Get a live stream up and we can be like, boys, what should we do? Chat. What should we be doing? So I'm on my own in my basement doing maths. Unsigned int, I think, just makes sense. Life is simpler. You don't have to worry about the 2's complement and what your sign would be. Which means padding zeros on the start is just trivial. Right. Let's have a look. So, our short-term plan is updated. We would like to do what exactly? We would like to say encode game piece config 28-bit output array. I hate using bit string. Which is essentially a number. And then we want to have a function that will accept a bit string, interpret value as unsigned int, interpret the value as unsigned int, and then output a base 36 representation of the number. Then that's all we need to actually do the thing, right? That gives us output and input. Cool. All right, I guess we better do it then. So, encode the piece config as a 28-bit bit string. Let's have a look. Where are you? Our README update just out of the way. In case we want to... Again, I'm a very messy Git user. I wonder if it bothers people watching. The place that I work, I guess because it's all proprietary software, it's not open source at all. So I think we've always said we don't really care about keeping the Git history neat. These things are generally there's enough commits going in that even if each individual commit is neat, it's still kind of a nightmare to dig through. So you still want to use some sort of tooling to search it or Git bisecting if there's something really gnarly going on. At which point, it's nice to just not have to think about it. And so I've gotten into what I think some people consider a bad habit. I just leave kind of work in progress commits everywhere as I'm going. I quite like it as a way. I've found it often you're working on a thing and you're like, I don't want to undo everything I just did, but I would quite like to get back to where I was 20 minutes ago. Um, and I know you could rebase before you push, but you're just adding more steps, right? It's quite nice to just be able to just splurge it out, and then really the commit history. I don't know. It's a tool that you use as you're working, and it just kind of happens to be there. It's like you're working out notes after you're finished. Um, so I'm just rambling now. Where do we put this? Game state, maybe? Where do we use game state? I guess actually, really, it's this global state that we're encoding, isn't it? I have initial game state, rotate active piece, acts on game state, save piece acts on game state, replace active piece with next acts on game state. Game state, game state, game state. We could just put it in here, but I think this might all get a little bit gnarly. So let's instead make an import export. We'll import core format, just so we've got it. And I would like to say here, piece config. Just call it encode. I want some types probably. Oi, how do you do type? Right, so encode piece config is going to take in our max piece is piece as the thing it's encoding. Just to check, if we jump to U. Yep, it's got nothing on it we don't expect. So yeah, piece buffer of max piece is piece. Sorry, where am I going? It's not state.odin. What did I call it? Import, export. There we go. So, I might even call it piece config. We'll output something. What is that something, is the question. I think Odin has like bitstring types that I've never really had to use, but looked like it had quite nice support. Bit set maybe? It's more if you're using it to represent an enum though. This website's so janky. Get up there. Can you just do any sized ints? So is there an option to say this returns a I28? Does not look it, does it? Can't assign 7 to invalid type here. I thought it did. And what does it return then? A slice of ball? Or just an array of ball? Can I say 28 Bit, is that a type? It's not a type. Byte, I think, is a type that's just a U8. I mean, that feels like the dumbest way to do it, right? Fixed arrays. Simplified and fixed length container. Right, dynamic arrays is not us. Fixed capacity dynamic array. Enumerations, enumerated arrays. Maybe it's just bit sets that I've seen then, because that's not us. Ah, or is it? We consider it like a bit set. No, because some of it's just numbers. Yeah, I think we end up just treating this as one big number. That's a shame. I thought there was some neatness in here that I was just not aware of. Unions, maps, bit fields. Bit field is a record type in Odin that is akin to a bit packed struct. Note, bit field is not equivalent to a bit set. It has different semantics and use cases. Bit field fields are accessed by using a dot. Foo bit field U16. Backing type must be an integer or array of integers. X is I32. Signed integers will be signed extended on use. U16. Am I being daft? I'm not understanding this. Okay, let's see. A bit field is different from a struct in that you must specify the backing type. This backing type must be an integer or a fixed length array of integers. This is useful if there needs to be specific alignment or access pattern for the record. If all the fields in a bit field are 1 bit in size and are a boolean, please consider using a bit set instead. Odin's bit field and C's bit fields might not be compatible. Oh, okay, interesting. I didn't know that was a thing in C as well. Odin's bit fields have a well-defined layout, least significant bit. These ones are not portable. Okay, so they're not the same. I think this might be what we want. How's it defined? Bit field, backing number, or integer or a fixed length array of integers. Okay. See, encoded piece config. A bit field instead of a struct. Then the backing type. Why has that not worked? Because I need to then tell it what's actually in it. I'm not understand what these pipes do. Is that it telling it how to lay these out? Is it saying that this takes 3 bits, this takes 5 bits, this takes a constant bits, and this takes 2 else 1? Truncates the value to fit into 3 bits. b.x equals 3. Ah, okay, so this 3 would normally be represented by something that's byte aligned. But this truncates the value. I got you. Okay, this does sound like what we might want then. Okay. But importantly, you can't be a U28 because that doesn't exist. Just have a skim. I was sure. Expression statements, procedures. Let's see. Odin unsigned int or int of any size. If the integer is larger than that, hang on, now I say I 12. Damn it. I was hoping this AI thing would pick it up and be like, oh yeah, here's how you do it. Built-in math types, memory management. Nothing obvious. Yeah, okay, screw that. We'll just use an I32. U32 even. How do you do padding in that case? Am I thinking about this too hard? Should I just use a number? All right, do you know what? We're going to just return a number for now. I think we're just going to do it very manually, and then we'll come back and see if we can make it nicer. So encode piece config. What do we need to do? We need to say, for piece in pieces, I'm going to call it pieces because it's what my brain went to immediately. What do we want to do? Probably a rotation center encoding first. Realize I think I've made a mistake. Each of these is 3 bits. So actually this is 6 bits. Right? Which means it's not that. It's 31. Which means that this is 31. Makes that 31. Nothing else changes. I do want to try this bit thing. Let's see if this actually is neater. All right, so we're going to say here encoded pieces, encoded piece config, which will be a bit field U32. We're going to have 1 bit of garbage. Is that how it works? Padding. No, so it's padding. Nobody cares about the type pipe 1. It takes 1 byte. We're then going to have our rotation center X. So I call it rot center X. Assuming that's in bits. Yeah. We're UX, but we're going to put it actually in 3 bytes. And rot center Y will also fit in 3 bytes. And then... Do I want to put all the rot centers in a block? And then all of the pieces in a block? Mm-mm-mm. So that gives you alignment, I assume. Right, so if we were doing one piece, we would then say here, the filled cells for that piece, which is, I call it piece data. What's the matter with that? Wouldn't fit. Is that what it was going to tell me? Going to say, sir, that doesn't fit in there. Too big? I guess what we actually want is that many balls. Right? The type of a bit field. You aren't allowed to be more than a byte. That's interesting. Is that right? So if this was an I-32, eh? The type of a bit field must be less than or equal to 8 bytes. 8 bytes, not 8 bits. Got 25. So I can't just do 25 balls. Okay, nightmare. That feels worse. Just working numbers. Right. Do them in turn. Output. That makes output start at 0. What do we say? We are interested in its rot center first, right? We'll encode X. Code Y. Code whatever the piece thing is called, piece dot build. And then shunt it into the output. That's 3 bits. That's 3 bits. That's 25 bits. Which adds up to 31 bits. We do that 8 times. So, how do we encode rot center X? Is we take rot center X, we divide it by 2. Oh, why am I struggling with this so much? You can tell I don't do a lot of this kind of like bit twiddling, because I think this is really easy. Let's have a look. So we're back in this world here. So rod center X comes in. Let's say it's 5. We need to get this value here. I think what we do is we say divide it by 2. It's a sorry, it's an integer division, so it'll floor it and give you 2. That is greater than 0, so we push a 1. The right way to think of it? Not sure it is. Ugh. Okay, how do you work out this 105? It's a 4 plus 0 plus a 1. Means that there's no 2 in it. So given the number 5, you can tell there's a 1 in it, because if I take modulo 2, so modulo 2, it gives me 1. I then say divide it by 2, I get 2. I take that modulo 2, gives me 0. I say divide it by 2, give me 1. Modulo 2 is equal to 1. Divide by 2 is 0. And we're finished. And that gives me my 101. To just check the typing on it, or the ordering of that, though, if this had been 4, that first one would have been 0, right? So if this was 4, the same procedure gives me 0 here. Still gives me 2, gives me 0 there. Still gives me... Sorry, hang on. So the division would give me 2. The modular then gives me 0. The division gives me 1. The modular gives me 1. So 1, 0, 0. So it gives me the numbers kind of in the reverse order to what I want. Okay. What are we doing? What type actually is rot center? It's I32, so it could be lots of things. Is there an assert? There is an assert. Condition, message. Rot center X is greater than or equal to 0, and rot center X is less than 6. Acquire value 0 to 5, or encoding strategy doesn't work. So it's true of that. Okay, let's make a little helper then. Go ahead and say, oh, what do I want to say? So I'm expecting 3 bits. Why am I struggling with this so much? I'm going to blame this on it being early in the morning. I do think this is turning into a bit of a dum-dum stream, though. So I've got a number. I assume that number, or I assert that number is between 0 and 5. And what I would like to do is I would like to have a function called, I guess, like binary representation. Call it rot center pos binary representation. Long name, don't care. We're going to take a position in one dimension or the other, which is an I32, because that's to match what's on the piece. And we will return 4s, 2s, and 1s. We could make that a list. Yes. Digits. 3 bool. Because then I can do it in a loop. Does my plan work for numbers that are smaller than 4? So if we get 3 in here, modulo 2 gives you 1. Divide by 2 gives you 1. Modulo 2 gives you 1 again. Divide by 2 gives you 0. Then you're finished. So yeah, as long as everything fills as 0, and then we fill from the index to end. So yeah, this will make everything initialize as 0. So what we've got currently is 0, 0, 0. Shadow P, so we can say 4 P is greater than 0. Digits written, it's not a constant, is 0. We go ahead and say digits at digits written is equal to P modulo 2. They're bools, so they will have to be done like that. Is there a U2 type? Or a U1 type even? No. Let's just use bool. This is where I think in C you can do that, can't you? But it won't in Odin because it has an explicit Boolean type that's distinct from integers. Whereas C, 0 is just false and everything else is not false. All right, P greater than 0, digits written, P modulo 2 is equal to 1. That's our logic in nya. And then digits written plus equals 1. P is reduced. I think we have to do this shadowing, or we're not allowed to do that. Yep. Get to the end and return. Hopefully that works. So what does that say? We put in 5. We come in here. P is equal to 5. Digits written is 0. 5 is greater than that. Digits written at 0. It's the least significant value. Checks 5 modulo 2 gives us 1, which is equal to 1. Writes the value. Digits written goes up, so we move our index that we're writing at. We divide by 2, so we go from 5 to 2. We then do this again. This is now not true, so we don't write it. We're still greater than 0, so we write the thing. So now 0, 1, pointing at the third digit, so the most significant digit. 2 becomes 1. Digits written does get written. That increments, but doesn't matter. We do that again. 1 goes to 0. This breaks. We come out. We have 1, 0, 1. Beautiful. So encoded x will be equal to rot center pos binary representation of piece.rot center.x. And we put that in nya, and we will go ahead and say that no matches. That should now be y. We get encoded y. And our piece encoding should be trivial, right? Piece filled binary representation. Representation is a proc. That will take filled, which is a piece data, I think it's called. Yup. And it will return an output that is 25 bools. And what do we do for that is we just go for cell in filled. If cell not equal to 0, you do like that. Then out index becomes true. They will default as false. We just do out index equals cell not equal 0 to do the same thing without the conditional, which I think makes it slightly easier to read. Possibly easier to optimize for the compiler, although compilers are smart, it probably would have worked out. For cell and index in filled, out index is equal to cell not equal to 0. So if the cell is 0, we get false, and if the cell is a number, because each of those will give us a number, then it's true. We put that in here, and we'll say encoded. Filled is equal to piece filled binary representation, piece.filled. Right. There's our 31 bits. How do we update output? I think for each of these bits, we want to shift output left by 1 and then add the value, right? Should we just have like an encode piece that does all of that and gives us out the 31 balls that we want? Code piece config. So let me just say here, piece binary representation as a proc takes a piece returns output 31 ball. Let's go ahead and say yoink that into there. Right. You can probably mem copy, can't you? But I'm just going to do little dumb for loops. So for I in naught less than or equal to less than 3. Output at I is equal to encoded x at I, for I in 0 to 3. Output at I plus 3 equal to encoded y at I. Quite angry. What have I messed up? Excuse me. Encoded y defined to be. This is wrong. Not like that's expected, no. Assert this. Looks fine. Well, I know this won't compile because I'm not returning the thing it should be returning. For I in 0 less than 3. Expected a type. Oh, it is this. Am I stupid? Is that not how you do for loops? I thought I'd be better at this by now. Range-based for loop. Ah, no brackets. Yeah, perfect. So, encoded y, we then say for I in 0 less than or equal to 3. Output at I plus 3 is equal to encoded y at I. For I in 0 less than or equal to 25. Output at I plus 6 is equal to encoded filled at I. You return. Still angry. Missing return statement at the end of the procedure encode piece config is further up. So we come back to here for piece in pieces. Have it just return 0 for now. Yeah, so it's happy. I think OLS might just be going a bit wonky. Alright, we'll ignore that error. For piece in pieces, we would like to say binary rep is its piece. Binary rep representation of the piece. I might restart Emacs because I don't know why that's not working. What other things does this give me? Describe session. Restart server is undefined. Can I shut the server down? Not defined. Can I disconnect from the server? Not sure what that's showing me. Alright, let's just start again. I don't think there's anything in my history that I care about. Come back here. That calmed it down. Yeah, God knows what that was about. That gets a binary representation. So we do that 8 times. How do we turn that into a number? The value's 0, and I keep trying to think about it. Sorry, I should be saying what I'm thinking. I was just thinking, how do we add the bit of padding? But we don't need to worry about adding the bit of padding because we're just working in like numeric values. So what we want to do is actually say, we take piece 0. It's going to be the first encoded piece. We get its binary representation, and then we just go through that. We say for b, for like bit in binary rep, output plus equals 1 if b. Don't know how you do that. Let's go do it like this. If b output plus equals 1, then output, you do that. And let me just check. That says left shift, which is essentially doubling it, right? It's like times it by 2. I think it's nicer to say it in shifts because I'm being explicit. I care about it for its like binary representation, not for its numeric value. So it writes a 1, it shifts it to the left, and it becomes 2, which in our binary representation means it's moved everything over by 1, which then left us room for... that's going to do one too many shifts, though, isn't it? It means when we write the last value, we're going to also shift that over. So I think you then have to shift it back 1. Is that right? So to write our piece, there's 31 things in it. We shift left every time. Like you write that first 1, it'll then get shifted left 31 times, which will leave it in. Let's think, if it was 3, 1, 2, 3, it'll end up actually in, I guess, like the 4th most significant place, right? It'll go from the 1st to the 4th. I think that's what we want. Oh, all this bit twiddling. Harder than fucking CSS, isn't it? Okay. But where does that get us then? We've now got what we think is a valid representation of our piece. We would then need to decode piece config. That does the opposite procedure. Input is a U32. And it needs to return us result. I'll call it pieces. Max pieces. Piece. Piece. Which will do what? We can do this destructively, I guess. We do that right shifting. It's the easiest way to do this. So if we take the least significant bits, that's piece 7, from 0 to 7. So let's see, if we have current piece is equal to 7, and down here we can have a 4, current piece is greater than or equal to 0, we have work to do. Right? So let's say we do that. At the end of each loop, current piece decrements. Again, let's shadow input so we can destroy it. Again, at the end of each loop, input shifts over 31 bits. What do we do? Rot center X will be input ampersand with a mask. Is that the right way to do this? So we want 3 digits, and then we don't want the next 3, and then we don't want the next 25. Can I do 0B 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5. That's 5, 10, 15, 20, 25. That's 3. That's 3. Oops. Let's do the same again, except that's Y. That's zeros. Like that. And build. They're all ones. That all lines up. I think that grabs us out the relative bits that we want, right? Which should give me a rot center. And again, I think we say in here, assert rot center X greater than or equal to 0 and rot center X let's type less than 6. Unexpected decoded rot center. So they're just easy checks to do that will catch if we've done something really obviously dumb. Okay, so given we've got them, we can now say pieces at current piece dot rot center is equal to, is it called grid pos X is equal to a rot center X, Y is equal to rot center Y. Blows up. Y blows up. It just types. These are unsigned. Yeah, so we can cast it. Cast to an I32. Cast to an I32. That should work. And then our filled. Right. How do we fill that in? I in naught up to but less than 25. Pieces current piece dot filled at position I. Do it in reverse. Position 24 minus I. Filled. Shifted to the right I times modulo 2. Shift amount I must be an unsigned integer. Modulo 2. It'll be equal to current piece if filled shifted modulo 2 is not equal to 0, else it is 0. Christ, that's hairy looking, but I think it does what we want. Alright, so let's get the value back out. So to get the position 0 in the output, we will actually get when I is equal to 24. We'll get it by taking that 25-bit string, shifting it right 24 times. We're left with just the most significant bit, and then checking if it's 1, basically. Oof. Hairy. All right. Well, that gives us something we can write a test for, though. I think Odin has a testing functionality we've not used at all yet. What are tests? At test. To do something like this. I have to do an import, and then you have to do this. Okay. Let's see. Import core testing. Import export round trip. So let's say I've got 8 pieces. No. All right. Let's do one piece first. Import export round trip with one piece. I should be able to say then, so piece equal to piece. What do you have in you? Rot center is equal to something x2 y3. Filled is equal to 25 ints. I'm going to say 0. 0, 0, 0, 0. Let's put a comma on the end of that. Right, so that would be 5, 10, 15, 20, 25. And we make a random bunch of these into numbers. Did I get the count wrong? That many. Okay, so there's a bunch of random ones in there. Pieces will be 8. Piece will be equal to piece. Then 1, 2, 3, 4, 5, 6, 7. Like that. Import, export, round trip, one piece. Get your pieces. And then we're going to say encode. What did I call it? Encode piece config. Should be less lazy and do piece width, piece height in here. Oops. Trying to remember what my thing is. There we go. So encoded looks like that. Decoded looks like decode piece config encoded. What do assertions look like? Testing.expect. Was it just take a check if n is the expected value? It takes a t, right, which is a pointer to our testing framework object thing. Then it takes a, what's it? How do I say? Odin on a like memcomp. Find. Just how do I? There we go. Nope, not what I wanted. No, I've done memory comparisons, but overview of intrinsics, types, procedures, expect, SIMD, loads of type stuff, WASM. I feel like I've ended up in the wrong place. I don't want the C one. Easily comparable, string, intrinsics, type is comparable. Core mem sounds more promising, doesn't it? Mem comp. What is simple equal? Check whether two objects are equal on a binary level. This procedure checks whether the memory ranges occupied by A and B are equal. Compare byte pointers for how this comparison is done. Maybe what we want. So simple equal from core mem. Let's try that. Import core mem. Mem dot simple equal for pieces and decoded. How do I run tests? Core testing, test.expect. With the Odin test command. No? Odin's a tool for managing this. So it will run. So it's not like there's just broken code. But it won't test. Why is that? Oh, damn it. This thing. Odin test. Yeah, it says it exists. Do I have to tell it a package to test? Is that it? Odin test main? Odin test runner starting test run. Defines a number of things. Finished one test, test failed. Expected mem simple. Alright, let's run it in a proper console. Mine slash Flectris Odin test main. Memory tracking is enabled. Expected mem.simple equal. Pieces decoded. Package done. Yikes. Didn't work. Can I permit print line pieces and permit print line decoded? Do we even get close? Let's get rid of all this nonsense. So decoded just has nothing in it. Interesting. Decoded should be writing to pieces here. Alright, what does encoded look like then? Alright, so pieces looks like that. Yeah, encode is just getting 0. Bugger. It's very much not working. So it is our encoding bit that's not working. Oh yeah, we're not combining them. No, we are. All this, encoded X. Alright, I say format, print line, encoded X, encoded X. Y get Y. Format print line. Coded filled. Coded filled. Make that a bit less messy. Alright, encoded X is 0, you're 0, encoded filled is false everywhere, everything's false, everyone's 0 everywhere. Interesting. I've clearly fucked this up. So, alright, so this is the easy one, isn't it? We're calling it up here. Pass in rot center X. digits written. To the end of each loop, I would like to format, print line, digits written, digits. Where are we looking? We're up here. Encoded filled, encoded X, encoded Y, encoded filled. Digits written. Why is it only there twice? False, false, false. False, true, false. So that should get called again for encoded Y, right? And yet, it doesn't. Well, it might be debugger time. We are writing it out, aren't we? I get P in this as well. P is equal to P. Format, print lie, initial, P, P. Let's see. So clear all of that. And test again. So we come through here. Initial P of 2. Yeah, because for most of the pieces it should be 0, 0, right? So we get initial P of 2, which is our X. Digits written 1 gets 0 because it's 2, and that's fine. Digits written 2 writes the true, and that's fine. Encoded X is false, true, false, which is fine. The 3 comes through and gets 1, 1, 0. Ah, is that backwards? I think that might be backwards from what we expected. Alright, because 1, 1, 0 would be 4 plus 2 is 6. Can I simplify my output? So, give me pieces 0 decoded 0. Because it's only that one that we're actually setting to a non-zero value. Alright, so what did I call them? I called it decoded. Got pieces and decoded. So pieces. Where's decoded? Get rid of a bunch of this noise. So pieces Gets me that first one with a bunch of stuff set. I think that might mean we're erroring. It's blowing up. No, because it is getting to this line. Why is it not printing decoded? I'm so confused. Am I just blind? Decoded. You just not. Problem. Don't do that. Load in test main. Where's all my printing? God damn it. I'm not enjoying this experience. Okay, testing dot expect t true. Just an actual assert that always passes. Why does it not just give me all of my standard out though? Make it false. What does it do then? No, nothing. Oh, what a pain. Oh, and it's 8. I think we'll have to go. Okay, I think. Let me. Let me what? Let me tidy up all these format calls. That's all a bit useless, but we want to make that pass. Right, that's the rub. It's a shame it doesn't print you something useful when it does that comparison. Let me see. Odin test asserts. Running tests, package testing. Procedures, expect leaks, expect signal, expect value. So what am I using? I'm using just expect. What does just expect do? Go away. So just expect. Just says. Is it okay? Take a message. Expect assert from. Let the test runner know it should expect an assertion failure. That's not me. Expect leaks. Expect signal. Cool. Expect value. That give me a more useful looking output. You go ahead and say expect value. Decoded. At 0. Expected to equal pieces 0. Be nice if it showed me expected and received. Expected decoded to be this, and it got that. Yeah, okay, that is nicer. Can I do the full decoded? The full pieces. Yeah, it is nicer. So now you at least got a thing we can compare. Although it's a little hard to read. Maybe we should make it a for loop. For I in naught up to less than 8. Again, let's do max pieces. We expect decoded I to be the same as pieces I. Block value expression. I don't know what that's saying. Expected decoded I. It's not going to tell me what the I is it? But I know that's the first one. Is there a nice way to put that number in the thing? Can I like print? Format print line I? Just so it's gives you a better idea of where you got to. No, it just spits one out at random. Alright. Well, for our purposes, that's a test we would like to see pass. It's not passing, and that gives us the most easily comparable thing. It's clearly shagged, because this just gives you zeros everywhere. I think I have to run, because we are out of time. And it's all very broken. So, something in all of this is not working. I wonder if the move might be to write unit tests for these individual bits. Really firm up. I think that's probably sensible. Unit test individual helpers to narrow down cause. It won't just help me with the debugging, it'll also then help as I make changes to make sure I'm not breaking other stuff. Because this all has to work very specifically. So, we'll save that. I'll probably actually try and do that in a separate session and then stick it in this same video. So this should be a nice big meaty one. So yeah. I'll catch you in a minute. Okay, good morning. It is the next day. Let's see if we can work out what the problem was. So where we're up to is, I think this all works best run in an actual terminal. Mine Flectris. If I do Odin test main, the test fails. We've done it to check each piece individually, and we can see that the first piece, which is the only one we expect to have anything in, gets... Oh, sorry. Something. Receives all zeros. So something is very clearly not working. And these are zeros too. So yeah, it's definitively not working. And I think my first idea is let's go back and unit test these helpers and see if we catch the issue there. Because I think I tested rot center pos binary position representation, got the wrong thing. So that should help us work out what our problem is. At test, rot center binary. I don't know, values. Let's call something like that. And all this guff. Set your test up. Make a make piece. Test make piece can be a proc. Returns a piece. Whip that out for now. I think each of these is going to want a test make piece. Cool. And if we need to do specific stuff, we can add arguments to that. Right. Although to be fair, this time, actually this one just takes a number, doesn't it? So I don't need it for this build. So what we're going to put in? Can't do 7. Start with 1. And then expected be 3 balls. Oh my god. False, true. Right? So it's like 0, 0, 1. Okay. What's the function called for testing? Or for expectations? We're going to do testing. Expect value. Go value, then expected. So T and what I called it. Rot center pos binary representation of input. It should be expected. Didn't work. Can I assign input of type int to I32? Can I do that? It should cast it. Alright, what's that telling me? Finished 2 tests. 2 failed. This one expected false, false, true, got true, false, false. Yeah, so it's backwards. Why is it backwards? To do that, and it's fixed. Alright, that fixed one of them. Can we go ahead and just do like slice I32 1 0 1 3 5, pick some subset of them. Expecteds. A slice of these. A slice of 3 long balls. I think, can I now do that, like make it anonymous? No. Oh my god. Okay. 3 ball. Expect you to look like that. We expect you to look like that. And that. Expect you to look like that and that. And 4. I in naught. Up to but less than. Len. How do I get the size of a list? Saying I haven't written much Odin for a while. No, size is going to have loads of uses. In fact, it doesn't. That's interesting. Oh, I'm in testing. Let's see, overview. Like lists and slices. Stores a pointer. Like I thought it was len. There we go. So for I and up to len. Do this. Input equals inputs I expecteds I. No? Cannot index a constant inputs. Right, I've hit that before. Maybe we should look that up because I don't know why that is. Okay, so just check a bunch of values will work. And they do. So, we're clear on one of them. That one works like we think it should. Okay, then. Let's see what about this one. We call a new piece filled binary rep. Piece filled binary values, we'll call it. Testing T. What are we doing? I mean, this one should be really easy, right? Let me go ahead and say filled is equal to test make piece. We grab our default filled values. Right. Expected will be... is this going to be the same thing? Have I just done it backwards again? Out index is equal to cell not equal to 0. Filled is test make piece filled. Expected would be what? 25 bool. Do this without having to type it all out ourselves. That'd be nice. We grab all that. And then we say inside of this region, make the zeros false. Grab it again. And we say inside that region, make the ones true. In this. Testing.expect value. Piece filled binary representation of filled should be expected. I really hope this one's worked because this is the easier one. So that is working. Also good. Have a quick sip of drink. To run only the failed test, use this. Huh. Well, that's good to know. Put in test clipboard to have this copied directly to your clipboard. Don't know what OSC 52 means though. Okay, so that's our encoding helpers. We're pretty sure are working. So, next part up the tree, we do this one. Oh, I've copied all of that. Piece binary value. Going to be a thing that takes a t, pointer to testing t. All right. Make our test piece. Oh, sorry, let me go test make piece. We've got our default piece back. Pieces, max pieces, coded pieces. Hang on a sec, what was my thing called? Encode piece config. Piece binary representation. So that's what we're after, is piece binary representation. Right center, piece filled. There we go. What are we doing? That on piece. Gives me output. What am I expecting to get? 31 balls. That should not all be false, but we'll make them all false for now. Testing. Piece. Nice. Output is expected. I got output expected. So what is it we're expecting here? So our test piece, we expect to see a 2 and then a 3. Right. That means we're in here. So this will be the XPOS. Then we'll have the YPOS. Then we've got the filled values. We're expecting this to be 2. So it should be false, true, false. All right, 0, 1, 0. YPOS will be equal to 3, if I remember right. So that'll be false, true, and true. And then filled will be all this guff. So going you, bang it in. Clear that, run that test. Cool. So how's that run? Where's the runner thing? Yeah, it's had 4 tests run, 3 passed. So up to the point we've turned it into our thing of balls, it's working. I guess still unknown is what number that gives us. Let's see, test. For the encode piece value. We have to work out what that number is. Alright, so we've got all that. Coded would be code piece config for pieces. Alright, so what should that give us? It should give us this. Minus the comments. We're going to undo our... Oh, bugger. We're going to go ahead and say all the falses should be zeros and all the trues should be ones. What do I do the first one? Like that. All online for me. Not good enough for my Emacs magic to do that myself. Alright, so we take all of that. That's 31. There is 32. Okay, so that's the first 32 bits. And then rest will look like the same thing. So we'll have 32, but all the ones are zeros. So let's go doot. Replace the ones with zeros. Right. How many of those are we meant to have then? 1, 2, 3, 4, 5, 6, 7, 8. Oh, how do you do the square? Why can't I remember? No. That one? Is it that one? No. Oh, that just grabs the whole word. That's useful to know. Ooh. Okay. That's a new command I didn't know. What was that? Control-Alt space. Right, let's just do it like this then. Grab all of that. Get rid of them. Get rid of all of that. If I delete, does it put them all on the next line? Yes. It does. Let's pull up this I think we do want though. Yeah. Same here. Okay, I think that gives us a U32 value there. Replace all of the comma spaces with nothing. Bang. And do the same again. Replace... there we go, all the spaces with nothing. Alright. That's way more than 32. No? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Am I stupid? Am I doing something really dumb? Is it that each of these outputs are U32? Where am I looking? Piece filled binary representation. piece binary representation. Yeah, you can't do it as just one big U32, can you? Because that's not 32 bytes, that's 32 bits. You have generic sizes. Can I just put anything in there? No. Ah, bugger. Well, there's a problem. You should be outputting a bunch of U32s, right? And that explains why we're getting 0 all the time, is that we're shifting our value off the end. What a Egypt. Yeah, I think I know that in bits, but I think my brain just went to bytes. And I was like, ah, cool, I need 32 bytes. I've got a 32 byte long integer. Oh, okay. I could test that's the case. If that's correct, I think all the way back. We'll ignore this one. I think this should pass. Oh, bugger. If piece is the last one in the list, right? The problem is we're left shifting all of our values out. This one, well, even if it doesn't pass, it should have something. Unexpected decoded value. What does that mean? Rot center binary values. Okay. I think whatever that means, I think we know what the issue is now, at least. Okay, so this encode decode thing's still good. I think these helpers are still good. All right. Bear in mind the goal is to get letters out. Yeah, so we just make it 8. We say that each piece is encoded as a U32. Then this is a max pieces U32. Everything inside of it blows up. This is max pieces U32, and everything inside of it blows up. We have a piece binary representation to U32 thing, though. Piece binary to U32. Rock. That will take in an input that's 31 balls. Turn us to U32. You're going to be called out. Output. Value and input. I'm doing B for each individual ball. Okay, so for each boolean in input, I'm going to say it. So each one of these, it says that the digits are 1. Output times is multiplied by 2 and then add 1. If digits 1, increment the output. Right. So iterate over all of those. And that first multiply by 2 does nothing, right? And that's how we end up with not having too many, I think. Alright, I'm doubting everything now. I'm realizing I'm bad at programming. We're going to go and test that. Let's go ahead and say piece binary to U32 val. Okay, proc. Testing T. This is nice though. This will give us a load of what? A load of oh my god, what's the word I'm looking for? Invariables. Invariants. Is that the word? So if we come back and we're working on this again, we'll know if we've broken something we've assumed. Should we just do piece? So piece will be test make piece. Its binary representation will be, I can't remember what I've called it, piece. Binary representation of piece, which we've asserted is what we expect it to be. And then we want to say that value is binary to U32 of that binary representation. Expected, currently an unknown number, and we wanted to go ahead and do testing.expect value. Testing expect T value and expected. It's not going to compile because other stuff is currently broken. That's slightly annoying. How do we work out what that expected is? I have got a calculator. All right, we're going to do it. Dumb and old-fashioned. So, going from the bottom, 0 1s, plus a 2, no 4s, no 8s, no 16s, no 32s, 64, 64, a 128, 28, a 256, 256, 512, 1024, 2048, 4096, 4096, 8, 1. Ah, no, that's a bad strategy. I'm already struggling. All right, let's not do that way. All right, we can find a thing online. Let's go from the top then. So false, true, false. False, true, true. False, false, true. False, 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 true. False, 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 true, true, true. False, 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 false. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Right, so let's grab that and go have a look for binary to decimal. Somebody else would have written this for us. Get out of here. Pop you in there. Cool. So if that's working, we expect to get that number. Can't run it because of all of, oh god, these issues up here. Decode piece config takes in max. Okay, Okay, let me just say to do make output. Sorry, make input. An array. But now let's just not worry ourselves about it. Put you back. Put you back. There we are. Only test failing is... It just me, is this hard to, like, grok? Main import export, there we go. So, we knew that was failing, which means that our number one is passing. Alright, if I make that a different number, we get 2 fails. Good. Okay. Now we need to go and break all our types. So to do, make input array. It was max pieces U32. What am I doing here? Right center X. So that's 1, 2, 3, 4, 5, 6. And then it's 1, 2, 3, 4, 5. 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so then it's 25, 31. So I've made a bunch of bit masks to pull out different values. But now our inputs map to outputs. I think we can do this more easily. So can we do for input in inputs like this? Don't think we need current piece anymore. I'm not sure what we were using it for. And we can get an index. So that's how that works. And this can now just count. Like that. What is current piece? Current piece was a number. This is dot filled. Jeez, what are we doing in there? I see what we're saying. We're trying to fill it from right to left. Yeah, current piece is now just index. No, so current piece used to count up. Pieces.index. Oh, what are we doing? Pieces index the current piece that we're filling in our output. We've just written its thing there and there. We've got the filled value by masking off the rot center values. But it's just a number at the minute. And so we're then saying that the value that I would like to write into my output piece is going to fill from right to left. Filled, right shifted by I. Modulo 2 to work out if that last digit is 1 or a 0. If it's not equal to 0, then what I write to my piece is the index. Oh, goodness gracious. Else it's 0. Now, we don't need to do those anymore because it's just a loop. All right, let's see if that works. And this one now takes that and that like this. And we now say for piece. Probably need the index as well. Get the binary representation of the piece. 4B in binary rep. We say now value is equal to that on the binary rep. Put index is equal to value. Beautiful. Try that. Test is still failing, but it did compile. Runtime assertion, unexpected decoded value. That's interesting. This is where it gets very clear that I'm not very good with the debugger. How do I run that in a debugger? Alright, so I go Odin, test main, define, Odin, test names, main, import, export, round trip one piece. It ran the test. Okay, good. If I then GDB that same command, right? It's not a binary, it's a command, isn't it? Bugger. Okay, hang on. Go run that. Odin test names started with this. The random seed is that. Memory tracking is enabled. Final total peak. Main this. How to get Odin test binary for debugger. Debug, and oh none. Okay. Then launch the debugger. Oops, setting up debugging. VS Code. Why am I struggling so much? Ugh. I'm just too tired. What are we going to do then? Right, so the round trip test is a nice, like, generic sanity test. I guess another thing we can say is if I do encode on different values, I can check to see if I get the expected values out. Right, so like the step, basically break this step and this step into two separate tests. They're still getting all zeros for that one. No, it's getting unexpected decoded value. Unexpected decoded. Oh, hang on. God damn it. Alright, let's see if I go X and Y. Right. Which one of them is it? Unexpected decoded X value. Interesting. Can I include... I say like formatted string. Odin formatted string. I like printf basically. So core format tprintf. Okay. Tprintf. And what is it? It's a number. So I think it'll look like that. Isn't that right? Huge number. Huge number. What's that about? Let me just get the same. Here, tprintf. I need to shift it, don't I? Right, I'm saying get me this value. I then need to right shift it 28 times. Oh, I'm an idiot. That one needs to be right shifted 25 times. And that one doesn't need to be right shifted. Okay. It's no longer blowing up. And it should have been blowing up like that the whole time. So that's interesting. Still getting empty. This time it's getting a grid pos. Cool. Progress. Um. Right. So it's now getting through that. It's saying in here, pieces.index.filled. I think this line is very suspect. Okay, I guess one thing to say is, are we getting anything in filled? We format print line filled. Clear, because I expect this to be a bit messy. Filled is coming up 0 every time. Interesting. Print line input. Oh, was I not looking close enough? Most of them should be 0, right? So underneath one thread is the number I'm interested in. Okay, yeah, so filled is not 0, which is good. Can I print you as a binary number somehow? Does that print it? Yeah. Yeah. If index equals 0, because otherwise we've just got a load of noise. No? Why is it not printing it? 1, 2, 3, 4, 5, 6. I'm only getting 6. There should be 8. No? Decode piece config. We're calling all the way down here in decode piece config for pieces, which is max pieces piece 1, 2, 3, 4, 5, 6, 7, 8. Oh, damn it. The more of this I do, the more stupid I'm feeling. Alright, let's go put our index in. And we'll have a little note to self that we definitely do need to go and up our debugging game. But hard to do if we've not got a executable. I wonder if there's a build test. Instead of that, running tests is in there. Is there a way to just build the tests? No. Is there a way to get an executable? Or a binary? Odin test log level? No. File? Didn't use cleanup. No, that sounds like what I want. Okay. We're abandoning that for now. I'll investigate that later and we'll get a debugger set up, but mildly bummed. Okay. Decode piece config, format printf, number filled, number. Going to assume that we are hitting everything and there's just something weird about the printed output that is swallowing some of the values because it just makes no sense if that's not go all the way up to the max value. How do I say print u in binary? Something like that. Oh, no. Let's see. It uses C styling. So let's say C format strings binary number. Oh, percent B. Try that. Did it do it? Hey, there we go. That's what we're getting. One of these tests, I think, has what we're expecting. Test make piece. It's binary value. All right, so starting at the bottom, 0, 1, 0, 0, 0, 0, 4 zeros, 3 ones. Then it's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 7. A 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then a 1, and then some zeros. Okay, so we are getting. We're masking things off correctly, which is good. Which means it's our dodgy looking loop that is the problem. Which I suspected, because it looks pretty hairy. Alright, so we're in here. Put I in this. What are we doing? Pieces dot filled. Pieces index filled 24 minus I. Our right index is 24 minus I. I guess let's just see what this is. And our value is index if build shifted cast uint I modulo 2 not equal to 0. Else 0. Just see what that gives us each time then. Alright, so all of these ones should give us 0, that's fine. Come up to find piece 1, which should be more interesting. Sorry, even piece 0, if we count from 0. So right index 24, meaning this one is 0. This one is also 0. Everybody is 0. This logic is bad. Right. We found the problem. Let's reconsider how we fill pieces index dot filled. Is equal to what? We've got a function that says take me from binary representation to U32. Why don't we just add a function that says do the opposite? All right, we have piece U32 to binary. Input U32. Output 31 bool. And we just do the opposite. Right, because this is the function we're doing, right? So for I in naught up to or equal to or up to or less than 31. All right, so for each value of output I is equal to input shifted right. Can we just do divided by 2 over and over? I don't know if there's a standard power function to call. What about we shadow input so we can change its value, and then we say for I in 31 down to 0. So we're going to count down. We're going to fill it from the right. Not allowed. Invalid interval range. Weird. Okay. So our right index will be equal to 30 minus I. Right. So right index is going to go from 30 down to 0, which will write into output from right to left. Say current value is equal to what? Input modulo 2 is equal to 1. If it's a 1, then we want a true. If it's not a 1, we want a false. So yeah, that's what that means. We then say output at our right index equal to current value. and input drops that digit. Return the value there. Alright, so because we've got that out on its own now, we can write a quick test. Piece binary to U32 val. So let's do the opposite. Piece U32 to binary val. Test, testing T. God, what are we doing? So our input 641794498. Our expected will be piece binary representation of test make piece. This is matching the test before it. Testing expect value, T value expected. Where value will be what? Piece U32 to binary on input. Can we just Odin test main? That test passed. Good. So, we're confident now that's working like we want it to. Which means we can say in here now. Oh, can we just do filled is that? No, because filled is 25. Hang on. Piece U32 to binary. If I just do that and take the last 25, right? That should still work. So if I go ahead and say filled as balls, that's equal to piece 32 to binary on what am I doing? Filled balls, piece U32 to binary on that number. But then I want to do a slice because I want to ignore what the first 6 values. No, not allowed. Not slice. Value's not addressable. Cool. Okay, there's some padding on it. Say padded filled balls is that then. Just go to the end. There we go. Filled balls will therefore be padded filled balls from 6 to the end. And it is addressable now because it's a named variable. It's not just some R value. All right, then 4. Ball and index in filled balls. If ball, should do it the other way around to avoid the indenting. So if not ball, continue, else ball is true, and we would like to write pieces. Oh no, I shadowed index. Filled index. Pieces index dot filled at filled index is equal to index. Still failing. Still getting zeros. God damn it. I really thought I would do it. Format print line. So in this case, wrote in pos. We wrote index in pos filled index. Right, so we're never hitting that. Can we have a format printf? Jesus Christ, come on, Matt. Print f bracket. Padded filled balls. This one can be ln because it's just the two things. Padded filled balls. It's always false. Interesting. It should be writing index +1. Because 0 is what we're using for empty. Hey! Nice. Confused about how that's coming out like that, but let's get rid of these. Oh dear, what did I do? There we go. Good lord. Made a real meal of that, didn't I? But what we can now do then is we can take our set of 8 pieces, generate a set of 8 U32s, and given a set of U32s, I can generate 8 pieces. The round trip works, so that feels well worth a commit. Say work in progress. Toward piece import export. Can turn pieces into U32 list. Oh my god. To list of U32 and retrieve pieces from list of U32. Beautiful. So like I say, that gets us, I guess, essentially like a binary representation, right? We can now dump the contents of the piece config, and we could just write that to disk or something and then retrieve it, which we might do later to make it so you can like persist your choice of config between loads. But more important than that, that U32 we can now write in a base 36 representation to get a string that contains only capital letters and digits. And now you've got something that my font can type that you can use to input that value in some UI. Sick. We should probably do a little bit in here. To just test other cases for import-export round trip a little bit more thoroughly. So import-export round trip, let me call this one first piece. We'll do one for last piece that's going to be exactly the same. And import-export middle piece. Right, so we're going to come in here and we'll do last piece. Testing T. We want all of this guff. We want it here. Instead of putting piece there, I'm going to put piece there. Like that. And for this one, I want to do the same thing, but I want to put it in the middle somewhere. Pointer to testing T. Bosh. Bosh. Typing failed. Again, yeah, instead of that, we'll have that one. Should pass. Doesn't pass. Interesting. Expected decoded I to be piece filled all of this. And it got... Ah, okay. That's my bad. That's because test make piece should probably take in... Yeah, an index. And this is where we hit. Odin doesn't have optionals, does it? So do I need to make that a pointer? Is that the way to do it? Let's see. Do you have a maybe or optional type? Maybe or option types are pretty much the base type plus a bool. They do work, however, I'm thinking about removing and just make you pass a bool in. Still a little redundant. Okay, so I'm guessing you can finish the game without Odin, miss some scenes in the story, learn Odin in 5 minutes, blah, 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 blah. Okay, I don't think Odin has optionals. Or else, an infixed binary operator that allows the user to define default values for certain expressions. Ooh. The above can be mapped to, or else, number. Interesting. Int. That's okay. Odin proc. Default args. Often useful when a procedure has a lot of arguments. When calling a procedure, it is not clear in which order these things. Therefore, the arguments can be named like a struct literal. As of that, you can mix them. This is often useful when a procedure has a lot of arguments or you want to customize default values. Default values. So you just name them and then you can give it a default. Cool. If I come in here, I say index is a... or is an int. Defaults to 0. And I can all just say index. Now that test should pass. The inputs are realistic. All the tests fail. Make that a 1, and that first one should pass, because that's what it would look like if the first test piece is there. And then we come into here, make test piece 8, 1, 2, 3, 4, 5, make test piece 5. There we go. Good. We should probably do one that has a bunch of pieces in it as well, right? So we know that we can miss pieces out. What if we do one that just has 1 and 3? Import, export, round, trip, multiple pieces. T is testing T. see. Go ahead and make pieces. Max pieces. Piece equals. Let's go test make piece. 1, 2, 3, 4, 5, 6, 7, 8. Wish we'd put a comma on the end of them all. 1, 2, 3, 4, 5, 6, 7, and 8. Cool. Didn't actually test anything. Let's go ahead and do all of these lines. Want to go in there. That should be called pieces, plural. Formatting, so it looks ugly. Check the test passes still, and it does. Okay. Honestly, I think that's probably good for what I want. Okay, so where are we up to now then is we need to output at U32 as a string, essentially. I keep yawning. It's the problem with doing these things in the morning. Oh, I'm running out of excuse for that now. It's nearly 9 if it was a work day. I'd be spooling up for work now. Okay. Yeah, I think I might tap out. I think I might call that success enough for today and stick a to-do in to say I quite like next, so I know to come here. Function that takes U32 encoded piece. Takes that U32. I guess really what I want to say is max pieces U32 input and returns our string. That's what I want to do next. Oh, what even is that? How do you convert between bases? I can't honestly remember. Convert between bases. Direct conversion. Use the expansion process to perform all arithmetic calculations using the rules for the type base. Base n to base 10. Multiply each digit by the power of the base, starting from 0 to the right. Okay, so base 4, you have 3 4s. They say go via yeah. They say go via decimal. So if instead of going to base 10, dividing by that number, from base 10 to base 8, divide the decimal number by the target base repeatedly using the remainders as digits from right to left, bottom up. You just give me a link. I'm sure this isn't hard. But it's just not going in my head. Do you know what? Let me go pause this for a second and just go check if everybody else is getting up. If we have a bit of time, I might have a dabble with this and see if we get it going. Okay, it is confirmed. I don't have time to do this. So we'll have to wrap this one up for today. But that feels like some good progress. And I'm sure that this problem of turning it into a string isn't as hard as it's feeling at the minute. I think I just need to sit and actually think about it for a minute. I wonder, is it the nastiest code I've written? A lot of big like arrays of test data. They're not too bad. Nah, I don't even think it's that bad. Okay, grand. Well, we've done a thing. I will catch you next time to do the next thing. See you later.